Hello, everyone. Welcome. Thank you so much for joining us today. Um, we have myself, Kayla, here from the Acelab team, and Jeff here from Brava Tile. We're really excited to walk you through today's presentation. Before we get started, though, I do want to quickly go over a few items. First and foremost, I want to take you over to Acelab real quick. So in just a moment, you should be able to see my screen, but we're here on Brava's page. Um, if you're not familiar with Acelab, it's a really great place to do material research. Anytime you're looking for a specific manufacturer, you're welcome to use the search bar at the very top of the screen. And as you can see here, there's some really great information here. We've got Jeff's contact information, some highlights, as well as their products for you to explore. So you can click into any one of these products pages and you'll learn quite a bit of information about their products. You can also save it to your firm library right here for future reference. So definitely check out their page when you have a moment. There's also some really great case studies here. So I'll drop the link to this page in the chat. That way you can check it out. And just a few other things to make note of. Today is an AIA-approved presentation. So we already collected your numbers upon registration. So most likely you are already good to go for that. However, if you're concerned we didn't get your AIA number, I'll drop a form in the chat as well. That way you can fill it out and make sure that we have your number. And then a couple other things, we will be doing Q&A towards the end. So if at any point during the presentation you have a question, just click that Q&A button at the bottom of your screen, drop your question there, and then we will read as many out loud at the end to be answered live. We will also be doing a poll during the webinar. So you'll see that webinar poll pop up on your screen about 3/4 of the way through. That poll is optional. So if you're not interested in getting any kind of follow-up information, just click the X, it'll go away. However, if you are interested in getting connected with Jeff and his team after today's presentation, fill that out with any information you'd like to get back. We will be sending you an email from Acelab, no reply email address. It'll be a notification that you have been connected with Jeff and his team. So you can actually respond directly to that email to begin communication, or you can log into your Acelab account and respond there. Again, it's a really great way to get any further questions answered or talk about any specific projects, anything like that. So definitely keep your eye on your inbox for that email after the webinar. And last but not least, we'll also be doing a post-webinar survey. So after we're done today, you'll see that pop up on your screen. Feel free to drop any feedback or anything you have there. But yeah, that's everything on my end. So Jeff, I will go ahead and pass it over to you.
Thanks so much, Kayla. Thank you for taking your time out of your busy schedule to join me for Sustainable Resilience, the Benefits of Synthetic Roofing. So my name is Jeff Soukup. I am the Director of A&D Business Development for Brava Roof Tile. We are a sustainable synthetic roofing manufacturer based in Washington, Iowa. So probably domestically sourced and manufactured. I'm going to go through the CEU. So here we go. So just getting some of the housekeeping out of the way. As Kayla mentioned, this is a CEU. We're also GBCI certified. Now on to the fun stuff. So the course description today. So during the Industrial Revolution, we're really looking at the development of synthetic materials. So why did this happen? How did this happen? Why did we start developing synthetic materials in the beginning? Well, we were looking for stronger, longer lasting, better performing material. And in this course, we're going to look through some of the developments, some of the notable product developments. We're going to look at some of the traditional roofing systems, the materials that they use, their new synthetic counterparts, and discuss how they differ in durability, lifespan maintenance, the carbon footprint, and then we are going to discuss how synthetic roofing can protect building occupants and a better performing building. Learning objectives today. So again, kind of redundant. We're going to review the history of synthetic materials. Why did we develop them? How did they come about? look at the real vessel for a lot of this learning is going to be roofing. So we'll look at, or exterior building products, but roofing as a focus. So we'll look at the traditional roofing systems, their synthetic counterparts. Again, contrast to the sustainability, and then discuss how great synthetic roofing is. So this picture, two light bulbs, but really we want to talk about innovation. So without innovation, where would we be today? Technology is moving so fast, solving tons of problems for us. And just looking at this light bulb, so we have the old filament incandescent light bulb on the left. We rarely use these anymore unless we're going for some sort of aesthetic, the Edison bulb. But lots of times, those are also LED now too. The fact is we've built a longer lasting, a better bulb that lasts longer, is more efficient, possibly smart, where we can turn it on or off remotely using an app or by voice. We can change the color temperatures, hues, all with a much lower life cycle cost and environmental impact. So we've literally made a better light bulb through innovation. And today, as I mentioned, we're going to talk about how we've made better exterior building products, specifically roofing, by innovating with synthetic materials. Just for a little thought, the world inside and outside is evolving, and the materials that encase it are quickly following suit. So are we keeping up with these material developments? It's going to be on us, the stakeholders of the A&D or the building industry, to make sure that we're looking at products that have a low impact and are long lasting and better performing. So the story of synthetics. So the innovation of synthetic materials has really led to the creation of beautiful, better performing, sustainable materials. Tons of uses, applications, including your decks, doors, windows, siding, trim, and roofing. So these are all materials that were, or all product categories that were traditionally a natural product, whether it's wood or stone or something else. Now, the majority of these, unless we're in very specific applications, are typically synthetic, some form of synthetic. So the origins of synthetic material. So just to paint you a picture, or set a bit of create a setting for you. During the early to mid 1800s, all across the globe, you're seeing a rapid population growth. So Europe, Asia's, Americas, Africa, you see tons and tons of population growth, and this creates an urgent need for housing, food, clothing, all of the basic necessities. To meet these demands, industries started expanding, producing, constructing, manufacturing, and this was great, but it placed a significant strain on two things: your labor and natural resources. And to overcome this, we had to turn to science and technology and improve our manufacturing and resource development. This shift led to a greater efficiency and the creation of engineered materials, semi-synthetics, and fully synthetics. So we began modifying abundant, potentially underutilized resources. We used chemical processes or advanced manufacturing to develop products that not only replicated the scarce materials, but often, because they were engineered or created, manufactured, we were making them better. So sometimes most of the time, they outperform their natural counterparts. And because we were in control of the supply and manufacturing, a lot of the times it's going to cost less. So best of both worlds. So now we're going to look at some really notable innovations, starting with Portland cement. So everybody's familiar with Portland cement. How did this come about? So Portland cement was created as a replacement or a substitute for Portland stone. Portland stone is a limestone that's quarried off the Isle of Portland in Dorset, England. Portland stone used throughout Europe on very grand projects because of its beauty. So projects are buildings like Buckingham Palace, Tower of London, London Bridge, many others across Europe. Notably, the UN is Portland stone. The challenge was it was only quarried off the Isle of Portland. So It's very scarce. It's going to be expensive to move, especially before we have transportation infrastructure. So Joseph Aston, whose father was a quarryman involved in quarryman or a mason, is looking for a substitution for Portland stone. So he decided, hey, why don't I just crush up some limestone, mix it with clay, some water, and heat it. And in 1824, he created Portland cement, which is still in use today. Just a really neat story. Vulcanized rubber, another material that we're all very familiar with. So Charles Goodyear, who discovered vulcanized rubber in 1839. Charles Goodyear was working with rubber. He actually had a failed venture with the U.S. or the Postal Service to manufacture rubber fabric mail bags for the letter carriers. He was using natural rubber treated with nitric acid to create the mail bags, but when it got very hot, the mail bags would fall apart, degrade, and he ended up losing his contract. But that was the impetus for him to really start searching to create a better rubber. He found another inventor who was working in New England, who was using a process, an inventor by the name of Nathaniel Hayward. He was treating rubber with sulfur, which was having better results, but wasn't quite perfect. So one night, and this is probably a embellished story, but Charles Goodyear is mixing this, he's cooking, and somehow he drops a mixture of rubber and sulfur onto a stove, creating vulcanized rubber. So he noticed after he picked up this material that it had a higher tensile strength, it was resistant to swelling and abrasion, and remained elastic over a greater range of temperature. This we still see today a huge impact specifically on roofing and waterproofing solutions. This is really a precursor to your synthetic rubber roofing membranes, but really neat story about the invention of vulcanized rubber. Poor guy was not actually part of the Goodyear tire manufacturing. That was the two brothers from, I believe, Ohio that created Goodyear and used his name as an homage. Engineered timber. So this is a really unique invention or kind of product history. So dating back to ancient Egypt, there are historians have found traces of cross lamination and ancient Egyptian, for lack of a better term, plywood. But it wasn't until the mid 1850s, your industrial revolution in England, that engineered timber really moved forward. So when we think of engineered timber, we'll think of LVLs, plywood, OSB, all of these sheet goods or flat goods. Uh, this was not the case back then. The real engineered timber really was adopted, and the real innovation started happening for the furniture industry. So if you think about the situation again, um, England or the the UK, an tiny island, you're limited forests, so they're depleting all the forests, and they're saving the good wood for their big projects, their buildings, other larger wood pieces. But the furniture needed to be made, so somebody realized that they could take the offfall from production, the shavings, they would add adhesive and began forming the engineered lumber for plywood. That kept on improving and innovating, and eventually they started creating plywood and OSB. But the real innovation for this was the furniture industry, and it's really notable that there's a continuing theme of doing more with less. So this is engineered lumber. Notably, that tube picture in the upper right-hand corner is an exhibit from the American Institute Fair in New York in 1867. So they created this as an exhibit for people to see. They wanted to show people what the Underground Railway in London, or it was inspired by the Underground Railway in London. So this is an elevated railway made entirely out of plywood. Um, Celluloid, so this is notable. This is the first mass-produced semi-synthetic material. So in the John Wesley Hyatt in the mid 19th century, this is the Victorian age, part of the Gilded Age. So owning a billiards table at this time was considered a symbol of wealth and status. So anyone that could afford a billiards table was purchasing one. But by this point, because of overhunting, so ivory hunters were out, they had really depleted, decimated elephant populations in Asia and Africa, sadly. So people were looking for substitutes for ivory. In 1863, things were so bad that a New York-based billiard ball manufacturer offered a $10,000 prize to anyone that could create a good substitute for ivory. $10,000 is about 250,000, so it's a pretty notable sum. And John Wesley Hyatt, his brother, and his brother created celluloid. So it's mixing cellulose nitrate and camphor, and they won the prize, but apparently they were never paid. But this is notable. So with their invention, they formed the Albany Dental Plate Company and to produce things like billiard balls, false teeth, piano keys, all of those things we associate with ivory. But also notably is that John Wesley Hyatt patented one of the first injection molding processes. So we don't really use celluloid anymore, more other than projection film. But injection molding is, any sort of synthetic or plastic rubber material. Lots of it is going to be done using injection molding. So this brings us to Bakelite. So Bakelite is the first mass-produced synthetic plastic. So in the late 1800s, natural shellac was widely used to insulate electrical cables. And while it was effective, it was very expensive because it was very difficult to harvest. So workers had to painstakingly hand scrape hardened resin from the inside of trees that the East Asian lac bug would leave. So scientists across the world were looking to create a better substance or a substitute for natural shellac, and they looked and started combining phenol and formaldehyde. Leo Baekeland was the first to succeed at this, and he actually created Bakelite. So this was called the material of 1,000 uses. Bakelite has really had a profound impact on the world, not only as an excellent insulator, but because it was durable and shapeable. It could have been found in everything from electronics to jewelry to automobiles to appliances. But it wasn't until World War II that we really propelled synthetics forward from laboratory experiments to really an indispensable war material. So when Japan advanced into Southeast Asia and cut the Allies access to more than 90% of the world's natural rubber supply, the AIA, Washington focused all of their resources into developing and manufacturing synthetic rubber and plastics. So they financed 51 emergency plants, and by 1944, those facilities were turning out roughly 750,000 tons of synthetic rubber, enough to eclipse all of the remaining natural imports, and really kept the Allied war effort supplied. At the same time, plastics such as bakelite, plexiglass, and nylon replaced scarce metal, glass, and silk in radar housings, aircraft canopies, wiring, and parachutes. So this really drove the global plastic output from about under 100,000 tons in 1939 to about 500,000 tons by the end of the war. So in 1945, post-war, we have this perfect storm for all of these plants that have been developed, the 51 that the Allies or the US started or created to remedy the situation, and no demand. So that's when we really started looking at, hey, what can we do with all of this synthetic material? And another kind of perfect storm, you have the post-war explosion in population, the baby boom, the VA loans where now everybody can afford a house. So that helped people start using synthetic materials in buildings. So that created our wide-scale adoption. So now we're in the age of synthetics. So the invention, really again is what revolutionized building materials. So if you think about how much plastic is used today in the building industry, it's really amazing. So we look at the versatility and durability. It's really changed how we build. Now the construction industry is the second largest user of plastics behind the packaged good industry. Synthetics have become really a preferred choice for exterior housing materials, from bottom to top, high performance, durable, and sustainable now, that they've really replaced traditional materials. And we constantly hear this refrain, specifically I do because I work in a synthetics industry, but natural is classic and classic is valued. My clients want real slate, my clients want real Spanish barrel tile, but there are challenges associated with that. So no doubt that these materials are beautiful. They are, the standard, but natural materials they do fall upon disrepair. They require very skilled and expensive maintenance and upkeep. Replacing is difficult. What once looked great, falls on disrepair, and it's very expensive to repair this. What once went in that was the envy of the neighborhood now has become unsightly, and it has a significant cost to repair or to maintain this material, and we're looking for better solutions as they come. Not only does this have a financial cost, but there is a significant cost in natural that we all pay in natural resources. So if you look at the replacing all the 2000 maybe buildings that burned in the California wildfires, just think about the amount of resources that we're going to have to deplete to rebuild those buildings. We want to start looking at how we can reduce our environmental impact, how we can create longer lasting buildings. And we need to really start considering alternative materials. How do we create more sustainable, durable, and lower impact structures? And surprisingly, the answer, in my biased opinion, lies in synthetics. And it really is. The modern building is synthetic these days. So let's take a look at some of the materials. You've already seen a preview of it, of product categories that have moved from a traditionally natural material to predominantly synthetic. Starting with siding. Siding receives probably the most attention because it protects our buildings from the outside, and has a range of synthetic options. So vinyl siding, the workhorse of the building industry, is durable, affordable, colors are very consistent, and it remains virtually maintenance-free for the entire life of the product. Engineered wood siding can mimic the look of your traditional wood material at a fraction of the cost. And newer sidings made from composite materials or fiber cement are manufactured with durability and sustainability in mind. Decks, so composite decking material first invented in the 1980s, taking wood pulp and possibly plastic bags. They weather better than wood, and they're virtually maintenance free. They're perfect for the ever-growing trend of outdoor living spaces. Wood decking probably needs to be cleaned, sanded, stained, sealed every 2 to 3 years. You're certainly going to be cleaning it nearly every year, but really a labor-intensive, high maintenance product. Our composite decking really answers the call. Vinyl windows rose in popularity in the 1970s when homeowners and builders were looking for more energy efficient solutions. They're one of the least expensive window materials and have a longer lifespan than both wood and aluminum. They also help homes improve their energy efficiency and come in tons of different colors, styles, and they're very easy to customize. They're very low maintenance. Since their invention, vinyl windows are definitely a preferred choice in the building industry. And then trim, fascia, soffit, all of these accessories, because wood trim, is vulnerable to rotting, cracking, and splintering, as well as pests and termites. Synthetic wood or synthetic trim had entered the market and really took over. So We're making pests and high maintenance care a thing of the past. Whether it's fiber cement, wood composite, cellular PVC, or modern synthetic trim, this really is outperforming, outlasting, and really is taking over for wood natural trim. So just looking at this picture, this building, from the roof to the floor, nearly everything is synthetic. Probably the only non-synthetic is going to be the aluminum gutters, but synthetic materials play a massive role in modern construction for good reasons. They're constantly being improved in order to stand up against the elements, increase energy efficiency, reduce maintenance, and last longer. So as you look for products to specify in your next project, consider how the materials are going to impact the environment and the durability of your structure. So I always encourage you to do your due diligence, specify manufacturers that have gone the extra step to offer sustainable options that not only meet your aesthetic needs, but are also innovative and help push the industry forward. So the greatest benefit to come from specifying synthetic materials is that we no longer have to exploit the Earth's natural resource, build and maintain the vision that we have for a home. Many times you can find a product with either post-industrial or post-consumer content where we aren't pulling materials from the Earth to actually manufacture. It may seem counterintuitive to admit that synthetic materials can help us be an answer for the store. After all, they are plastics that once made life convenient and now something many of us are actively trying to avoid. But even synthetic materials are a cheaper resource to create affordable housing. And they allow us to extract fewer natural resources while improving the lifespan of our building and increasing the home's efficiency. So looking at synthetic roofing, again, my biased opinion, they're a very smart choice. So this says, no building is complete without a roof, but I'd argue a stadium is complete, but here nor there. So we're going to look at a few of the traditional materials again, and just juxtapose them against synthetic materials. So the earliest known form of roofing tile was found in the Temple of Hera at Olympia. So if you think about like 2,000 years ago, over 2,000 years ago, we were making clay tiles. So across the world, clay tiles were used for residences, shops, temples. Tile was considered an art form. If you look at thatch roofs or wooden shake, they've been used since the 1600s. Slate has been used since maybe the 600s or the 700s. But each of these materials has really helped define different architectural styles, and they're still very valued today, but they all have challenges associated with them. So cedar or wood shake, one of the biggest challenges I see across residential and commercial markets is getting a building with cedar roofing insured. It is nearly impossible in some markets because of the hazards with wood, so fires, rot, pests. So these, while they are extremely beautiful and natural, they are difficult to get insured. They're expensive to maintain. It requires a very skilled artisan for installation and maintenance. That's not always available. And if you are treating this for fire resistance, you're using spray-on retardants, which could possibly have forever chemicals or release arsenic into the water supply. So it's really a challenge. Lots of beauty, but also lots of headaches. Slate, long prominent material in Europe, the US, and some parts of Canada. This is largely driven by having large slate quarries nearby, but slate roofs, they have a great curb appeal and last very long, but they're really fragile. So while installing slate roofs, every single tile has to be properly handed. Even after they're installed, walking across a roof is very difficult to do. You need to know where to walk to safely navigate a roof. Failure to do so, you can possibly damage your roofs or damage your tiles. creating the opportunity for more moisture intrusion. And it typically takes a very highly trained contractor to achieve good results. Also noteworthy, we're going to have to over-engineer our roof structure. So slate being so heavy, you really need to consider the added structural support that's required for a slate roof. Similarly, clay tiles are extremely beautiful. But like slate, they're heavy and brittle. I was talking to an installer, and he said he factors in 15 to 20% just in breakage for clay tiles. But they look great, but they need to be maintained. They're very fragile, and like slate, they're very heavy. So you need to make sure you're properly supporting your structure. But the good thing is, with synthetics, we now have replacements for this that are lightweight, durable, and very easy to install. Um, Gen 1 of synthetics was a bit of an issue. So if you've been in the industry for a while, you've probably heard, oh, synthetic roofing, it's not a great product. If you think about the idea behind it, it seems great. But if you're trying to create a slate alternative using plastic, you put a black piece of plastic just sitting in the sun all day, it's gonna crack or peel or fade if you don't have the proper science behind it. And that's exactly what Gen 1 did. Thankfully, you know, we've come a very long way, and synthetic roofing is now time tested. We've invested tons of money in research and development, new manufacturing techniques, materials and product testing, and installation methods have really developed over the last 10 or 15 years to create roofing materials that are going to hold up longer than their natural counterparts while looking nearly identical. So the synthetic roofing industry has grown 30 to 35% over the last 5 years every year. So it's a huge, becoming a large category. If you were going to look at a product life cycle arc, I would say synthetic roofing is where either fiber cement siding or composite decking was 30, 40 years ago. We are very early on, but it's becoming a more and more the norm every year. So what's synthetic roofing made of? Synthetic roofing is made from a mix of rubber, plastic, and other polymers. Obviously, it depends, changes by which manufacturer you use, but they can be either virgin or recycled materials. Some manufacturers use only virgin materials, while others incorporate or are entirely made of recycled content. But it's important to note that even synthetic roofing made from virgin materials without recycled content is a less environment or without recycled content, even though it's a less environmentally friendly option, it does have the expanded lifespan, which overall helps reduce the overall carbon footprint compared to traditional materials. So if we can keep it continuously out of the landfill, if it can be recycled at the end of its life, then it's still a very green friendly product. Plastics, so many manufacturers are using recycled plastics. So whether it's post-industrial or post-consumer, synthetic roofing manufacturers are helping divert waste away from the landfills. Many synthetic roof manufacturers use mineral pigments to enhance the color and vibrancy and even durability of the material. So looking at the carbon black, red iron oxide, green earth, azurite, burnt umber to do this. In addition to being made from recycled materials, product design is really big for us. So recycled composites are able to be recycled again at the end of their life cycle. So we're going from a cradle to cradle or a cradle to grave to a cradle to cradle design strategy. So this is very important. We're going to want to look and make sure that all of the materials that we're using are able to be recycled at the end of their life. So a big question about synthetic materials, or how would they perform over time? Would they perform like your asphalt tiles or your EPDM? Are you going to be able to achieve your fire ratings? And the answer is yes. So fire, you know, again, the early concern was how would they withstand fire? Were they really any better than wood, or could they even perform like wood? And the answer is yes. So synthetic materials are tested for fire resistance using the UL 790 test. So this provides our external fire ratings, which fall into three different classifications, your A, B, or C. A being the most resistant, C being the least. This this image right here is of the burning brand test. So this test, we take a satchel of burning wood, throw it on a roof, and see what happens. Does the roof catch on fire? Does it make its way all the way to the deck? How badly is it? And using that coupled with your spread of flame test and the intermittent flame test, we determine their classifications. So the spread of flame test is, you set your roof on fire and see how the spread works, or you expose the roofing material to fire. If it catches on fire, then you see how far it spreads. Intermittent flame, again, kind of mimicking either a wildfire or just a traditional fire. You're exposing your roof to an intermittent flame. Does it catch, and how badly does it burn? All of these go into your fire rating, your Class A rating is very effective against severe fire tests. Your Class C rating, effective against light fire tests. Um, most synthetic roofing will receive a Class A fire rating, or at least can achieve a Class A fire rating through assembly. But this really is quite the feat, and you're really going to want to look for a manufacturer of synthetic roofing that can offer a wide range of products that meet or exceed your common industry tests. Another one, impact. So very notable. So in the mid-90s, a series of catastrophic hailstorms came across the US, and the roofing industry wanted a test to evaluate its products against or for resistance to hail, and they created the steel ball test. So the steel ball test is, they're not very creative. You're taking a steel ball and you're dropping it on roof, or your roof. So what we want to see is how much can we endure. So you take from an 1.25 to a 2-inch diameter steel ball, and you drop it from 20 feet twice in the same spot on the roof, and then you evaluate the results. So is there any moisture excuse me. Is there any moisture penetration? Is there breakage? How does this perform? Nearly all synthetic material is going to be Class 4, and will likely exceed any of those tests. If there was another, classification or a class higher, most synthetic manufacturers would meet that. Wind, another commonly, asked about one. High velocity synthetic materials were made for high velocity. So many have Miami-Dade County approval, which is the most stringent. So manufacturers will warrant up to 110 mile per hour wind with modified installation techniques. And most of the time, those modified installation techniques are just switching from a ring shank nail to screws. Testing has shown that synthetic roofs are much more likely to endure impact and wind than many other options, including your clay, asphalt, or metal. Furthermore, aim for synthetic roof tile manufacturers that can withstand your freeze-thaw cycles as well as extreme heat. Synthetic tiles are also mold resistant. They won't absorb water and can be installed in the winter months. So the advantages keep on coming. Some manufacturers of synthetic roof tiles also build in UV protection into each tile, so that's aided by natural mineral-based colorants. But again, just the features and benefits continue to grow. So you're really seeing durability without sacrificing your style. So, the old synthetics, as we were looking earlier, they could be considered cheap or inferior or low class. Now, the new modern synthetics are nothing like their predecessors. They are luxurious, beautiful, and sustainable. just some examples of what a synthetic roof can look like. So this is a mountain house in, I believe, Colorado. Authentic profile appearance, and it really creates a dynamic roof that enhances the property. So you have custom blends, shades, colors. Synthetic increases the curb appeal, and makes your building protected from the elements. So just a juxtaposition from what the old materials look like. And these are your new synthetic counterparts. But not only for residential, lots of projects being used in commercial applications, from multifamily to institutional, restaurants, retail, just tons of opportunity all across the board. Religious institutions, huge opportunity for this. We've moved from to a synthetic style. Well, synthetic style is really one that lasts. And you'll have to apologize. This one was supposed to be by the other. Oh, I doubled up. So just a final kind of thought, for you, the way your work holds up over time is going to be, it's your business card out there. It's your business card, it's your legacy. So if you are selecting, when you are selecting materials, make sure that you can, you're selecting materials that will last long and remain beautiful for the entire time of their usable life. Other considerations, so, the weather's not getting better. We're just continuing to have these rare events, which they're not rare anymore. They're just happening all the time. We want to start looking at some of the new codes that are popping up, specifically your Title 24 Part 6, your cool roof. So look for manufacturers that can have a positive impact, can help insulate your house, protect against the environment, and last longer. So we've entrusted with Earth's natural resources. It's time for us to start making sure we have a better future. So looking at some real life cases or examples of this. Oh, hold on, I need to, some case studies. So this is a home in Florida where they wanted the look of cedar shake on their home, but really understood the challenges of living in Florida and maintaining a natural cedar shake roof. So thinking about the Florida Keys, you have heat, UV exposure, hurricane force winds, and corrosive material. The ocean's inevitably going to push across the roof. With all of these factors in mind, this homeowner went synthetic and was able to get the look of cedar shake with the durability of a synthetic plastic. Again, this is the Lodges of Sundance in Colorado. They wanted to redo their roof. After time, they came back and found out, hey, you are no longer able to use cedar shake here. So the Mountain Village or the property manager was able to find synthetic cedar. She presented it to the Architectural Review Committee, and it was approved. Now the building is insured and has a beautiful, long-lasting roof with the look of synthetic or with the look of cedar. Again, another synthetic cedar shake. This home is sitting right on the edge of the Pacific. The same challenges that many of the other materials or the other examples face. So they went with synthetic cedar and got the roof that they wanted. Finally, this project, multifamily project in Dallas, they wanted they wanted clay tile, but they were having troubles negotiating back and forth with their insurance company. They wanted the durability, so they were able to go with a synthetic tile, a Class A rated synthetic Spanish tile, and achieve the design, the look, and the protection that they were searching for. So conclusion, we've gone through, looked at the Industrial Revolution, saw how engineers and scientists created these newer, stronger, waterproof, long-lasting products. Look, the advances in technology that led to the creation of better performing, beautiful exterior building products. Just looking at some of the differences between traditional materials when used in roofing to their synthetic counterparts. And really looking, synthetic roofing is fully recyclable, made with recycled materials, and has a longer lifespan than many natural materials, and doesn't require the depletion of Earth's natural resources. Now you can review the history of synthetic building materials, compare traditional versus synthetic roofing, contrast the sustainability attributes of synthetic materials, and then discuss how synthetic roofs can protect your building. So that kind of taking off the AIA hat and putting on my Brava one, I just wanted to quickly run you through Brava. So I work for Brava. Brava manufactures synthetic roofing made right in Iowa. So we have a great US manufactured, US sourced material made. We like to say that we're creating a unique and meaningful built environment where people live, work, play, or live, work, or play. Make 3 profiles, your cedar shake, slate, and Spanish barrel tile. So we were founded in 2008. We are still manufactured in Washington, Iowa. We manufacture beautiful products right there. I think we just hired one of our 500th employee earlier this year. So we're growing rapidly. We're actually expanding to a production facility in Georgia. So you'll see and hear more from us. So Brava Roof Tile. So what is it made of? Brava specifically is manufactured from post-industrial and post-consumer recycled content. So we're using anything from bottle caps to plastic bottles. We're using materials other than bottles, but that's all I'm thinking of right now. But most of the material that we're using is post-industrial. I'd say over 60 to 70% is going to be post-industrial. The rest is going to be post-consumer and mineral pigments and other polymers. We are working with Green Circle to get some certifications. The challenge for us is the supply of usable post-consumer material is a little bit more difficult than, or to find a reliable source. So post-industrial, we will add to your lead points, but we're diverting materials from landfills, which is really the goal. So we use natural mineral pigments. Again, your carbon black, red iron oxide. Mineral pigments retain colors longer. So our products the color is all the way through, and they are long-lasting natural pigments, which do not degrade like a synthetic pigment. So, artists throughout time have used mineral pigments to create their art, and that's why they last so long. Synthetic pigments, as you can see, what we're familiar with, photographs or print magazines, they will fade over time, and that's why we don't want to use them in our roofing material that's going to sit in front of the sun all day. So here's just a little slide talking about our mineral pigments. So what separates us from a lot of our other synthetic manufacturers? So we are sand casting our natural materials, so your slate, shake, and Spanish tiles. We are using those sand casted molds in compression mold. This creates our authenticity, so the sand casting, but also when you take our material, because we essentially manufacture by heating everything up, combining all the polymers and mineral pigments, and then we extrude what's kind of like a Tootsie Roll, and then we compress it. So when it compresses, it creates this natural variegation that you see in our tiles that other synthetic injection molded products do not, because of how they manufacture. Bravo is nearly maintenance free, wind resistant, fade resistant. So we have a 10-year fade resistance warranty. Wind resistance, we've gone up to 212 miles an hour in a chamber test or a wind uplift test. and we had to stop testing when the roof deck pulled off. So, just very, very strong, durable material. We're thicker than other manufacturers, and we are very lightweight compared to natural components. So as I mentioned, we have 3 different profiles. We will soon have a flat tile that's coming out, but shake, slate, and Spanish are big ones. This is an arboretum in Ohio that I just think is beautiful. These are different materials. We have Title 24 cool roof colors if you're joining us from California. Our installation is very similar. It's nothing special. We have all of your accessories that you would require. So slate, just a very realistic, beautiful, natural looking, authentic product. Some fun colors in here. And then our Spanish tile, which you can find all of these on Acelab's website. Please let me know if you would like samples. I'm happy to assist here. Want to get to the questions and answers, so I'm kind of blowing through these. This is, I was discussing earlier, so where I think we are in our life arc, we're in strong growth mode. So we're really, you're going to continue to see synthetic roofing pop up. I encourage you to utilize Brava. So here is a life cycle cost analysis that was performed by the roofing industry. And you can see Brava, because of our durability and lack of requirements for maintenance, really gives you the lowest life cycle cost. And it's really going to be important for us to hammer on life cycle cost to increase the adoption here. Lastly, we have a full team of training or field service reps who are available to make sure that your project goes according to plan and make sure that the installation that you are getting is top notch. And this is me. All right. Hand it back to you, Kayla.
Yes, let's see here. All right, pulling up some questions now. We do have a few in the chat. So, folks, if you have any questions, now is the time. So, I'll go ahead.
Sorry to interrupt. I would like to add that we will be at AIA 25 this year. So this week, please stop by our booth if you're going to be in town. It's booth 147. I will be there, so you get to put a face to a video face.
Yes, no, I'm glad you remembered that.
Yeah.
Yes, very exciting. Awesome. All right. So, looks like I've got somebody asking if you'd be willing to share the slides. Is that something you're able to do afterwards?
Absolutely.
Okay, perfect. We'll get
Sure.
you then. All right. And next we have, is there slope options? Oh, sorry. Is there low slope options and standing seam looking options?
We don't have a low slope or standing seam option yet. We are developing a flat tile, which will, I guess, get closer to the low slope. But right now, we can go from 312 up. So that is the lowest slope that we can go.
Gotcha. All right. And next, this is a bit of like a two-part question here, but is there any consideration for attachments as related to earthquake resistance, like seismic attachments? Also, is there a single tile that's about 2x6 or like a pattern tile 2x2 or greater size? Both questions
So,
related, big tile
so
size.
the
Yeah.
oh, I'm sorry.
Yeah, it's kind of like I think you get the gist of it.
Yeah, so our material, if you're in a seismic zone, I wouldn't be too concerned about our material. If you wanted to go and attach with screws, that would be probably the best installation. But it's really going to be the substrate that you're going to pay attention to, however you're planning for seismic activity. Regarding tile sizes, the smallest we have is a 5-inch tile, and we don't plan to. I don't imagine. I could ask if we plan to go smaller, but the challenge is getting. We want to have 2 fasteners in each tile, and once we start getting below 5-inch, it's difficult for us to get good penetration and spread for our fasteners. So I don't see that, but I would never say we're not going to do something.
Exactly, yeah. Awesome. I think that's helpful. Do you mind actually going back to your slide with your contact information so I'm able to
Yeah,
for it? That way you guys can copy that down. Awesome. All right. Looks like, let's see if there's anything else right now. All righty. Yeah, I think that's everything right now. And looks like we're coming up on time anyways. So,
yeah.
um, is there any final comments you'd like to make, Jeff, before we wrap things up today?
Yeah, as far as architectural resources go, if you are looking for samples, I know there's options to request it, but please let us know if we don't have smaller resources, but we can send out tiles and we'll work with you to get them back. We're in the process of having PBR textures created. They should be available probably within the next month, and I will have some RVT files created shortly. So hopefully we will have all of our ducks in a row for our architectural partners.
Yeah, that's great.
Yeah.
Awesome. Yeah. And just like I mentioned earlier, folks, if you filled out the poll, we'll get you connected with Jeff via a conversation in Acelab. So you'll get a notification when that conversation has been created. So look out for that in your inbox. It'll be coming from a no reply at Acelab email address. You can reply directly in the conversation with Jeff, or you can log into your Acelab account and respond to any conversations there. But we definitely encourage you to use that line of communication to ask any specific questions or ask follow-up information on a project, anything like that. But keep an eye out for that. And yeah, I think that's everything. So thank you, Jeff, and thank you everyone who has joined us today. We appreciate it.
Thanks so much.
Have a great day, everyone.